Good morning. Welcome back from your long 3-day weekend. As we start quarter 2, we're going to be talking about rational functions. We're going to start talking a little bit about their graphs. So first off, what is a rational function? That'll be any function written as a ratio, and hopefully you see the word ratio right there in the word rational. So it's written as a ratio of two polynomials. So essentially that means we have variables in the denominator. All right, so how that affects us for graphing is that we're going to have a vertical asymptotes. All right, asymptote, one of my favorite math words. So what is an asymptote? Well, an asymptote is a line that is approached but never touched, skipped over. So lines that correspond to the zeros in the denominator of a rational function, that's where we get our asymptotes. So you can see here's a little example, f of x equals 1 over x. Well, you're not allowed to ever have a 0 as a denominator. Anything divided by 0 is undefined. And how do you graph undefined? Where do you find it? Well, there isn't one. That's the point. So that's where we get our asymptotes. So anytime that there's one, again, where the denominator is 0, it's not allowed, that's how we find asymptotes. So here's two different examples of what pictures could look like. First one here on the left, we could just have what's called a hole in the graph. A hole in the graph is where the graph continues on the same path. It just skips over this one spot where it's not allowed to have an answer there. All right. Other times, you can see in the second one, we get a graph that approaches, if I can spell right, approaches but does not touch. It's kind of a hard concept to picture in your head of two things getting closer and closer together and never touching. No matter how close you zoom in, they never actually get to each other. They just keep getting closer and closer. Again, it's kind of a hard concept to comprehend. All right, so let's try some problems. Our job today is to find where the vertical asymptotes are. So what we're going to be looking at are some rational equations. And again, what makes it rational, there's a variable in the denominator. And our job is to make sure that that denominator does not equal 0. If it equals 0, then that's where an asymptote is. And that's what we're really looking for today. So what we're going to do is just going to take that denominator, set it equal to 0, and solve. In this case, I'd just add 6 on both sides. X equals 6. That is where I'm going to have a vertical asymptote. That means this graph, 1, 2, 3, 4, 5, 6, over here at 6, we'll have this dashed line, and the graph should be approaching it, maybe like this or something. I'm not quite sure what the graph looks like yet. We'll get to that in the upcoming days. But again, I first got to figure out where those asymptotes are. And so that's an easy one. Let's try a little harder one. All right, again, if I want to find an asymptote, I'm looking for the place where the denominator equals 0. So I'm going to set x squared minus 25 equal to 0. We got a couple of different options on how to solve this one, but because there's only one x term, there is no plain x, just the x squared, we can still split this and solve it the old-fashioned way by adding 25 on both sides. And then, of course, to get rid of a square root, an exponent too, we use square root. So I square root both sides. And remember, square roots have two answers, plus or minus 5, which means this one actually has two vertical asymptotes. One over here at positive 5, and one over here at negative 5. And again, it could be doing all kinds of crazy things, going up over here, and then maybe going up this way, and then maybe coming this way. We just know that there's asymptotes there. We don't know enough else about the picture to know for sure what's happening, but we do know that there's two asymptotes on this one. One at 5 and one at negative 5. And again, I hope you didn't forget about the negative version of that answer with the square root. Right, this one's a little bit tougher, but also probably more what you're going to see partially today. All right, so once again, we want to take this denominator, x to the third plus 9x squared plus 14x, and make it equal to 0. Well, what I'm hoping to do is I'm hoping to do some factoring. I would like to get this to the place where I'm reversing FOIL and doing some factoring, but that won't work with the x third. So what I do see is that all three terms have an x. So I can factor out a common x, leaving everything with one less x than it currently has. And now I can factor. I'd be looking for two numbers that when I multiply them I get 14. So my options would be, well, there's 1 times 14 or 2 times 7. Now one of those pairs should also add or subtract to make 9. So it's obviously the 2 and 7. Now when I add or subtract, I always keep the number from the bigger, or keep the sign, sorry, from the bigger number. And now out of the 7 and 2, the 7's bigger, and I'm supposed to be keeping this plus sign from the bigger number. So the 7 was plus. Now is it 7 plus 2 that makes 9, or 7 minus 2 that makes 9? Oh, it's 7 plus 2, so that's got to be a plus also. But if you remember, those aren't the answers. The answers would be everything that makes the answer 0. And what we really have here are 3 parts. 1, 2, 3. Any of those 3 parts could be 0. Now the first one should be easy. The only thing that could put a 0 in that original x is a 0. So there's our first answer. All right, taking care of that one. The second answer is when x plus 2 equals 0. Right? Minus 2 on both sides, and it's negative 2, the opposite. There's our second asymptote. And our third one over here, that'll be whenever makes x plus 7 0. You had minus 7 on both sides, and it's the opposite. So this one would have 3 asymptotes. Again, it would have one right here down the center, another one over at negative 2, and another one out here at negative 7. All right. A lot of your work today will involve factoring, kind of like what we just did here. But again, I did a little bit harder one. So your work will be somewhere, between the first one and here. Some easy, some medium, and then maybe a couple of harder ones like this. All right, you know how to get a hold of me on the Zoom if you need any help. Have a good day and good luck.